So in this tutorial we are going to design the DC to DC buck converter, and first of all I will drag DC voltage source. I'm using power library, so use the second one. Okay, now I need one MOSFET, one pulse generator, one series RLC branch, one diode, okay, and current measurement block, voltage measurement block, display, power GUI, and scope. Okay, now let's connect it. I'm connecting DC voltage source directly with drain, and now giving pulse to the gate, and after that I have to connect the inductor. Select only inductance, and I will give values later. This is my inductance L. This is my capacitance C, and this will be load resistance R. Okay, first place a current measurement block in order to find the source current or switch current, then connect inductor, freewheeling diode in reverse bias. After that connect capacitor, now this ammeter is for the measurement of capacitor current, and now connect load resistance. I am connecting current measurement block in series with the load. This is my freewheeling diode, this is capacitance, and this is load. Okay, now connect voltmeters. This is my input voltage, voltage across the inductor, voltage across the capacitor, voltage across the diode, and voltage across the load. Okay, now this displays for the output voltage. Now I have connected 3 ammeters. Actually I have to connect one ammeter here also for the measurement of diode current. Okay, so 4 ammeters and 1 2 3 4 voltmeters. Okay, now I am giving 50 volt input. For pulse generator I am giving 1 volt, amplitude of 1 and period of 1 by 20,000, and 20,000 is actually 20 kilohertz frequency, and duty cycle of 50%. Okay, and inductor current, this is actually diode current. Now how to calculate the inductance? Actually I am using 20 ohm resistor. Okay, now go towards the MATLAB. Now if I am using R equal to 20 ohm, then there is a thumb rule for finding the inductance and capacitance, that inductance should be 10 times the value of the load resistance. So R is equal to, so L is equal to 10 times of R, so it is 200 and it is in micro Henry. So L equal to 200 micro Henry. Okay, and also capacitance is equal to 10 times of the inductance. So this is the value of capacitance. Okay, now I am placing value of inductance. Here, and value of capacitance will be here. Volt input, this is inductance and this is capacitance. Here it is 20 ohm load. Okay, now I want to plot inductor current and the output voltage. For that purpose I will use my scope. Now change its axis into 3. Okay, now at first axis I want to see pulse, so I am connecting pulse at the first point. At second point I want to see the inductor current, and then I want to check output voltage. Okay, let's run it. So you can see here that for 50 volt input and with the duty cycle of 50%, I am getting 24.54 volt, and that is expected from a buck converter with a DC input of 50 volt and a duty cycle of 50. And as you know that output voltage is equal to the duty cycle times of the input voltage, so 50% mean it will reduce the input voltage into half. So for input voltage of 50 volt, I am getting 24.5 volts at the output. Now let's see the graph. So here are the graphs. This is my pulse that I have given to the switch, and this is inductor current, and the output voltage is plotted here. You can see it is nearly 25 volt. Also you can observe that my inductor current is above the 0 ampere. That means my inductor is in continuous conduction mode. Also you can see that whenever my switch is in working condition, or you can say my switch is closed, then I am getting this type of pulse, and in this point I am getting my inductor this value. Inductor is increasing linearly, or I can say that it is charging, and after my switch got open, my pulse goes to 0 and inductor goes into the discharging mode. So this is the discharging pattern of the inductor. Also, if you want to see the capacitor voltage, diode voltage and the inductor voltage, we can plot on different scope. Like first of all, this is inductor voltage, this is diode voltage, and this is capacitor voltage. Also I will do small comparison with output voltage, so let's make it 4. Number of axis 4. Okay. Okay, so you can see this is the inductor voltage, this is the diode voltage across the capacitor, and this should be the, I think I have given same voltages to the scope. Yes, this is output voltage, and this should be, this was capacitance, and this should be output voltage. Yes, now so you can see here the inductor voltage across the diode, and the capacitor, and the output voltage. So these are all the plots that are relevant with the buck converter. So you can do the analysis according to your requirement, the values which you need in your labs or in your research work.